Alright, so we'll just quickly set this up to record the noise. So this is easier with full parameter list. INS log. Right, so we've got mask. I'm going to set that to 1, which gives us, there's only 1 OMU, and then I set bat up to 4, which gives pre and post filtering. And then I might just set log bit mask. What have we got here? So this is the default log bit mask. I'm going to turn on PID logging just so I can see the PIDs. Not going to turn on fast attitude because it'll just swamp everything. I think everything else should be good. So with that in mind, I can do a quick hover. I won't show you the hover, I'll just do it and get hold of the log. So just do that quickly now. Right, done a quick hover. So let's download the log. So I'm here on Wishing Planner, download data flash. This is on the data tab, download data flash. Got this one, I'm going to pick the last log. Alright, and then let's use Pete's little tool. Pilot web tools. So there we go. I'm going to filter a view. Download a file which will be somewhere in documents, mission planner, logs, quadrotor 1. There we go. That file. Alright, so now we see, yeah, a little hover, pre and post filtering. Doesn't look too bad. Okay, it actually looks very good. So you can see XYZ here are the pre filters, and this is, so you can see that we're up at 300 Hertz at hover, which is amazing. And you can see then this noise is completely knocked down by the filtering, so that's working really well. This is another reason why setting the loop rate to 800 is actually quite important, because 300 Hertz is way above the Nyquist frequency for a loop rate of 400. So if you want to start doing, you're just not going to be able to do some of the sort of PID filtering that you might do. So that looks pretty good. Very nice. And there doesn't seem to be any kind of frame resonance that I can see a bit here. So okay, so that looks all very nice. And then I suppose we can also look at the PIDs here. Quadrotor 1, this guy. so here we are. So PID, roll, target, actual. Well, not bad. Really not bad. Pitch, target, actual. Again, not that bad, I'd say. Yeah, down here. And it's yeah. And then I quite like to look at P versus D just to see. There we go. So this shows that D is working harder than P. I mean, it would show up better in a fast attitude log, but you can see amplitude of D is higher than P, which is generally bad. It's not it's not horrendously high though, but an auto tune will fix that. So basically D is too hot, P is too low, but the net result seems to be relatively okay. So I think as initial tune goes, that's pretty good. All right, so before I try and switch to auto tune, it's going to require me to fly an alt hold, which means because there's no compass or GPS, the copter needs to be very, very level to stop it drifting. And one of the things that will stop that happening is temperature drift to the IMUs, because otherwise the EAKF will learn sort of quite bad biases, and I really want to stop that. Like, it has no reference point to learn good biases. So what I want to do is alright, I want to set temperature calibration, which doesn't seem to be enabled in this build, and I need to figure out why. I figure it's because it's a 1 meg build, but since we only build this for Arducopter, it should fit. So I'm going to figure out how to get temperature calibration in the build, and then I can put the copter in the fridge, start things off that way. So I'll go and figure out what's going wrong with the build, fix that, take it from there.